All right, so worksheet 3B, we didn't finish a few application problems, and I do want to revisit graphing logs. And then we're going to talk about worksheet 6 today, which I realized we skipped the finance stuff. We'll do that next week. So we will come back and do finance. Today we're going to talk about condensing and expanding logs. So my s'more practice, or my warm-up problem today, one of them anyway, is on graphing this log. So a log base 3 would look like what, guys? It would be the inverse of what? Yes. So it is the inverse of 3 to the x. So 3 to the x would look like this. So the inverse is going to look like this. Okay, so this is the one we're looking at right here today. Except, what are the transformations that have happened here? So right 3 and up 1. Okay, so the asymptote was originally for a log equation, the y-axis. So if we move it right 3, it's going to be at -3, or +3, sorry. The intercept, anybody know where the intercept was to begin with? If we had, this one would have been y to the power of 3 equal, let me try that again. Yeah. 3 to the y equals x. So if we put in a 0, we would have gotten out a 1. So 1, 0 was the original intercept. What happens when we move it 3 to the right and up 1? So right here went 1, 2, 3 to the right and up 1. Okay. And can we maybe find one more point at least? If we had this original function and we put in a, let's go with a 1. For the y value, 3 to the first would have been 3. So we'd have had 3, 1 right here. If we move it 3 more to the right and up 1, I think I did that right. All right, so I'm thinking this is our sketch. Domain. Okay, range. Asymptote. Good job. And intercept. It's ugly. Yeah, it's not nice. Yeah, I wouldn't worry about it. It's not like this on the quiz, it's a basic one. Let's talk about how you can graph this on your calculator. Okay, real quick. If you had one of my calculators or an 84 or above that has an updated operating system, you can graph other bases and evaluate other bases with the log base button, which is under math. So if you go to y equals, and then you went to the math button at the very bottom of the list, so it's honestly faster to get there to arrow up. And if you find this log base and hit enter, it'll let you type anything you want in there. So we can do base 3. What was this one? X minus 3, was that right? Was it 3 to the right, guys? Minus 3 and a plus 1, okay. Minus 3, and then outside of here, plus 1. So, whoops, in a standard window, it would look like this. Remember what I told you though about using the calculator? Right, this does not end, okay? If you put in, well, if you traced, okay, and it looks like it ends here, but if we went closer to 3, like we put 3.0001, it is still down there, okay? Just doesn't show up on the graph. Any questions about graphing logs? Did everybody find that button on your calculator? Because that's going to be your friend if you're not good at this stuff. No? The log base button? So that you can do a log base 3. All right. Again, it's under math. It's at the bottom, so it's faster to arrow up. And it's choice A here, log base, and that will let you put a base in. Okay. If you don't have a calculator that'll do that and you want to borrow one of mine for the test, I'm not going to tell you you can't. I actually have the capability of turning that button off on the calculators if I put it in press to test mode. But Abruzzo and I haven't discussed doing that, so. Did you find it?
Yeah, but I pressed
Okay, just do quit, which is second mode. The other thing you can do on the home screen with that button, if you do math and you do the log base, what did we discuss yesterday? Log base 2 of 8 should be what? 2 to what power is 8? Okay. So I need to talk to Abruzzo about whether we're going to let you use that button, but it's there. There is also a shortcut for it. I don't remember it. There it is. It's alpha window. It's alpha window, and then it's the number 5 one there. Okay. I just knew it was under one of the F function keys, but all right. We did not do the rest of worksheet 2B. Does that sound right? Is this 2 or 3B? 3B? Do you have this number 11? This is just a quick application. It gives you R equals 1 over T ln of P divided by P sub 0, where T is time, P is present value, and P sub 0 is the original investment. So an investment of $4,000 was made in 2005 and had a value of $7,500 in 2010. What was its average growth rate of investment? How could we fill that all in? Anybody know what T would be? 5 years, because it went from 2005 to 2010. ln of P is present value and P sub 0 is original investment. So which one goes on top? Which be the 7,500 and then 4,000 down here. All right, so can you type that in? And I unfortunately turned my calculator off instead of just minimizing it. All right, I already forgot what it was. 1 divided by 5, is that right? And then times ln of, was the 7,500 on top? Divided by 4,000. Anybody get that?
Yeah.
Okay, 0.126-ish is an interesting answer. Does anybody know why? So the rate of growth was 12.6%. In this economy, that would be awesome. Especially over only a 5-year period. All right, number 12, the doubling time T or the amount of time it takes for an investment to double, is generally estimated by using this, where K is the interest rate written as a decimal. It doesn't say that we have to put in the amount of money, right? It says generally to figure out how long anything's going to double, you don't need to know how much money's invested. All you need to know is the interest rate. If Tara's parents had invested $5,000 in an account that earns 4.5% interest compounded continuously, will it double in 5 years? If not, what interest rate do they need? So right now, where are we going to put this number? I don't know why it doesn't say R, but did you see here it said K is the interest rate written as a decimal? So we have ln of 2 divided by 0.045. Can someone do that quick? You would have to close the parentheses around the 2. Anybody else get that? I was going to say, I don't think you can double your money that fast. So this says it's going to take 15.4 years for her money to double. So the answer to the first question, will it double in 5 years, is no. Okay. What interest rate do they need? So what do we do to work it backwards? What do we want to know? What do we want it to double in? So where are we going to put 5 years? ln of 2 over K. So we're looking for this rate K. So if I multiply the K over here and then divide by 5, so what rate would ln of 2, close parenthesis, divided by 5 give us? Point something? Anybody? What'd you get, Dakota? 1.39? Okay. Did someone else get 0.139?
Yeah.
Okay, so they would, if they wanted it to double in just 5 years, they would need what interest rate? Yeah, almost 14% interest, okay? That's why your money doesn't generally double in just 5 years. All right. This is a graphing question, so let's just, do you even have this one? Okay, but everybody grab your calculator and let's type this equation in. We're going to graph this. The equation. No, I don't think you even have this, but let's just type it in. 6.8 plus 20.1 ln of x. So this is logarithmic growth, but it's been shifted how or stretched how? If the parent function was just ln of d, it would look like this. Okay? But this has been what? What is that one doing because it's multiplied? Stretching it and it's shifted. It's not inside with the d, right?
Right.
Yeah. No, so it's up.
Oh.
Okay. So in our window, I'm thinking we're going to need, I mean, you can try Zoom 6, but I think we don't need negative x's. I'm going to go out I don't know. I didn't read the rest questions. So I'm going to go out 30 years, we'll say. But I think it's going to be up. Let's put in like 50. How did I do? Yeah, it's still going off the top. All right, let's put in 100 for Y. Is that better? All right. So my window, in case you needed it, was 0 to 30 and negative 10 to 100. About how many machines were infected on the 12th day? This is the number, this is the rate at which, what did it say was growing? Computer virus. So we would trace to the 12th day and say about 57 machines roughly. Can anybody trace out to the 30th day? That's got to be in your window, or look at the table. 75. So it actually says how many more machines were infected on the 30th and the 12th. So that would be what, 18 maybe? Did I subtract right? I think so. 18 more. And then the third question is, on about what day will the number of infected machines actually hit 75? Sounds like we already found that. But how would you find that with a graph? Well, you want it to hit 75, so if you put in a line at 75, then you could figure out where they intersected. I'm going to go out past this just in case I need to. And then you would find the point of intersection. And it is right at day 30. Okay? So it's weird that they asked that question for B, but. All right, so your homework on this, I showed you last night, but now that we've started talking about the applications, I think you can better be prepared to do those on 178. All right, the properties of logs is where we're going today, 3.3. This is worksheet 6. And we're basically talking about condensing and expanding logs. That's it. Oh, I have a warm-up because some of you need to desperately retake this. How does this denominator over here factor? 6 and r plus 3. So what's the common denominator? Okay, r plus 6 and r plus 3 is multiplied by r minus 2 over r plus 6. And then it's multiplied r plus 6 times r plus 3 times this mess. But that's already over an r plus 6 and an r plus 3. Do we just leave a minus 1 back here? No, we got to multiply it by an r plus 6 and an r plus 3. All right, so in the first one, what happens? Quick. So we end up with these foiled together would become 3r minus 2r would be 1r minus 6, right? Okay, all of this divides out here, so we get an r squared plus 6r plus 8. And back here, when we multiply by this times 1, we just get all of this. Do you remember what this was before we unfoiled it right here? Before we factored it, it was r squared plus 9r plus 18. Okay, and it's a negative 1, so we need to distribute that. So we'd have a minus r squared, oops, a minus 9r and a minus 18. What happens? This r squared goes away. What do these two combine to be? Okay, and if we're moving it to the other side, we'd be adding it, right? And these two combine to be negative 10. If we're moving it to the other side, we're adding it. R squared plus 4r plus 4. How would that factor? Yeah. So we got, what is the solution?
R.
-2. What were the domain restrictions? -6 or -3, so this solution should check. All right, a little bit better on those. All right, we're going to talk about log properties today. They are closely attached to the properties of exponents. When you had x squared times x to the third, what did you do to the exponents? You add them. So we got x to the fifth. So when you multiplied the bases, you added the exponents. Okay? It's going to be the other way with logs. What about this one? When you had a power to a power. Oh, that doesn't, I don't have those above the right problems, do I? Can I move that? Whoa. That goes above this property, but anyway. I'll talk about that one next anyway. What do you do here? If you have x to the fourth 5 times, it means this. How many x's does that become? Yes, you multiply these. Okay, so a power to a power, we multiply. And then these are just dividing out, so we do what to the exponents? Subtract them, so we'd get x to the fourth. All right, those have opposing properties when you talk about logs. When we had x squared times x cubed, we got x to the fifth, we added. So when we see log base 2 of, say, 5 times m, you're going to expand that by saying log base 2 of 5 plus log base 2 of m. Do you remember this a little bit now? Okay. You were multiplying, so you added. Here you're multiplying, so you add the 2 logs. All right. If it was dividing, so you had x to the 11th over x to the 3rd, you would get x to the 8th. You were dividing, so you subtracted. So the same is true if you have the log of n over 6. You're going to rewrite it as the log n minus the log of 6. And if you have to the power, so you have, you had an x to the 3rd to the 4th, you would have gotten an x to the 12th. You multiplied, right? So if you have a log base 7 of x to the 11th power, you multiply this out in front, and it becomes 11 log base 7 of x. How many of you remember all those properties? 2, maybe? 3? Okay. Or because if you don't, you need to work on memorizing them. So you have them at the top of your paper. You don't have this example. I just wanted to do an easy example real fast because the book ones get hard fast. Can anybody help me with this one? Do you remember what happens? You're going to write log base 8 a whole bunch of times. What does multiplying mean? Multiplying is tied with adding. So you have x plus log base 8 of y plus, yeah, that one goes out in front. Good job, guys. You remember this. Log base 8 of z. Those are easy, right? Okay, what happens over here then? Okay, so just this piece would be 4 log base 6 of x minus 6 of y. Good job. All right, before we get any further, if I saw this, does anybody know what I'm supposed to do with that? What's the power of that? Yes. You need to rewrite it as a 1/2 and then move it out front. So you'd have 1/2 ln of x. Everybody good with the radicals being powers? All right, so you have an evaluate question. let's just look at this piece first, maybe. What is 2 to what power is 8? Okay. 2 to what power is 4? So what do we get? Right? That would be a great question for me to ask on a quiz without a calculator, but we're not doing a no calculator part, so you're in luck. The peach sheet that you got today, guys, really was for the no calculator part, because like if you saw log base 7 of 343, can anybody see 343 on there? I think it's on there. Is it 7 to the 3rd power? So what is the answer to this? 3. Okay. That's what it was used for when you had a no calculator quiz. So those are some good things to have handy when you're doing the homework, but we're not taking your calculator away this year. All right, so help me expand. Oh, this one's done for you. You guys seem pretty good at this. Can I just move on? That one's done. Let's try some more together. Okay, I don't think you have this one, but I want to talk about one with this root thing. What does this mean?
1/3 log.
So this is log base 6 of 36 to the 1/3. If I move that out front, can we evaluate this? What's log base 6 of 36? 6 to what power is 36? 2. So it's 1/3 times 2, or 2/3. All right. What about this one? No, I don't think so. This 9 moves out front. Anybody remember what's ln of e? Means e to what power is e? So it's 1. So this is just times 1. And back here, if we move this out front, we have both a 4 and a 3 out front. So this will be a 12. And again, ln of e is 1. So we just get 9 plus 12, or 21. Everybody all right? All right. So what about this one? You have this one. Can you evaluate this? 3 to what power is 27? Okay, so we have 2 times 3 plus 4 times, anybody know? 3 to what power would make it 1/3? Is 3 squared 1/3? Is 3 to the 3rd 1/3? Yeah, it just moved to the denominator, right? So it's just -1. So we have 6 plus -4 is 2. All right, I'll humor you. I would rather you could do these in your head, but on the home screen, if you were trying to do that problem, would be a whole mass of typing, but you would have 2. Then you could use alpha window or math button to find that log base. And then you would put the 3 down there and the 27 back here. And then you'd arrow to the right out of that box. Plus 4, alpha window to find that log base. And 3, arrow to the right, 1 divided by 3. My gosh, by the time I got that typed in, I could have done the question 6 times. Did everybody get 2? Sorry, guys. All right. Unfortunately, this is what the book does with expanding. They make them very complicated. So, first of all, we have, I'm just going to rewrite this real quick. We have a 5 times an r to the 5th, and it's divided by, can anybody rewrite that as a power? Yes. Does everybody remember that? The cube root is 1/3, and it's squared, so it's 2 times 1/3 or 2/3. All right, now help me expand it. Log base 3 of 5, then the times would be plus. That one can move out front, right, of this log base 3 of r. And you could write it here first, and then realize it needed to move out there. Yes, and then we need to subtract, and we'd have log base 3 of t to the 2/3, which can move out front of that one. Glorious, huh? All right, before we try the next one, I think I have a slide reminding us this somewhere. This is not true. The log of a quantity cannot be distributed, okay? If you had like a squared up here, you could write it as 2 ln of x plus 4, but whatever this is in here, you can't mess with it. So going back to this lovely question, we have this quantity times this quantity to the 6th divided by this to the 5th. Anybody think they can handle that one? What you got? Nope. So you write log of a minus 2, then the times in there becomes plus. Is that a 6? Okay. And it's a log of b plus 4. Yep, Hofbauer's out of room. Can I move this over? Oh, love my smartboard. Okay. Minus 5 log b. Okay. Just remember, if you do have to write, if it was like base 3, you have to write base 3 every time. We were lucky this one was just base 10 or common log. All right. I like condensing much better, but I do have students who get really confused when they do condensing because they want to write on like this one, what does minus mean? So they want to write log base 7 of a divided by log base 7 of b. Okay, when you condense, you only write the word log one time. That's why a lot of times in the directions, I will say condense into a single log as a reminder, okay? I don't think you have these. These were pretty basic ones. I just wanted to do log base 2 of. Where can this 12 go? So this will become x to the 12th, and this 6 will go here. So now I have a plus. What does the plus tell me to do with those? Multiply. So I get x to the 12th, y to the 6th. You don't have that one, right? Okay. This 6 can move up here. This 12 can move up here. But what does minus mean? So I write a single log base 7 of what? Everybody good? All right, so let's do the ones you do have. All right, remember, when you have parentheses around a quantity, you just leave it. So this 11 will move up here. This 5, any ideas? What do we have to do with that 5? Well, we're going to put it up here, but it goes on. Yeah, but the 5, we'll worry about the negative in a second, but the whole 5 goes on the whole 2x, just so we're clear. And the minus means what then? Divide. So we have log base 9 of what's on the top? X minus 3 to the 11th. And down here we have a 2x all to the 5th. Now, could we simplify any of that? Well, in theory, we could do the 2 to the 5th, right? And just make that I think that's 32 to the 5th, x to the 5th. but that's it. I would take either answer if it was that complicated. I apologize, guys. I can't ever decide if I'm writing my L's which way. They'll look different every time I write them. All right, so you could do that too. All right. I don't know what they want us to do over here. A single ln, 3/4 and 1/4. Okay, so the plus means what? Times. So we have a 2h plus k. What does the 3/4 mean? Do you remember which number does what? Nope. What's the root? 4th root. So we have the 4th root of this to the 3rd. The good news is this one back here is also what? 4th root, and it says to multiply them together. So we could just put this. I would not give you this question, just so you're clear. That's the 4th root to the 1st power. Now, those are the same though, right? 2h plus k?
Yeah.
What's 2h plus k to the 3rd times another 2h plus k? 2h plus k to the 4th under the 4th root is just what? Yeah, so we just end up with this. Yeah, that's not going to be on a quiz because it's nasty. That's not that mean. Everybody okay? Oh, need me to go back? All right. I don't know if you have this one. Just extra practice. Can anybody, you know what? Maybe I'll skip that and do it as a warm up next week. Let's move. Do you have this one? Okay. Let's talk about change of base. Change of base was used all the time because calculators didn't have it says most calculators only have 2 keys, log for base 10 and ln for base e. Therefore, you have to learn to do the change of base formula. Okay, this is what change of base, this is how I think of change of base. Can everybody just look real quick? If you have log base b of x and you're trying to evaluate it and find what it's equal to, okay? Rewrite this as an exponent sentence for me. This would mean b to some power equals x, right? Okay, my calculator doesn't have a log base b button, which a scientific calculator does not have. You would have had to take either the log or the ln of both sides. Now, what can I do with that little square? What did we just learn today? I can move it out front. So I'd have this times the log base b equals the log, or the log of b, log of x. And then I could divide to get this little square by itself. Okay, that's the change of base formula that they've written right here. So if you have log base 6 of 11, which one goes on the top? This formula says you take the log of one divided by the log of the other. Which one goes on the top? So you do the log of 11 divided by the log of 6. It's the log of the full size number, okay, divided by the log of the subscript. It's always the bigger one over the littler one. And I don't mean bigger number, because it could be, this could be a 6 and this could be an 11. But it's the physically bigger number on your, okay? And you could do it with ln, it doesn't matter. Let's try it, okay? Can everybody type? use log of 11, close parenthesis, divided by log of 6, and then do ln of 11, close parenthesis, divided by ln of 6. Do you see that it's okay to use either natural log or base 10 as long as you're using the change of base formula? All right, so do these three questions. You have these three, 6, 7, and 8? Okay. So what would you type for number 6? Log of 631 divided by log of 32, etc. And you can use ln. Now, if I leave you to use that change of base button and I leave it turned on, you could always use that as well. Yes. Or that log base button. No, it doesn't have to be. I could, in theory, ask you the log base 20 of 1/2. Okay. Anybody want to read me their answers real fast? What'd you get for the first one? Nice and loud. Anybody? Okay. The second one, anybody else? And the last one, anybody? That far? Dakota, do you have the last one? Did anybody else get that? Negative? Yeah, because this is saying 0.5 to what power became 420. So the only way, if you keep multiplying by 1/2, it's going to get smaller. The only way to make it bigger is to raise it to a negative power. All right. We're going to stop there for today. We'll do some more together next week. Last thing I want to say, if you start working on worksheet 7, they write it this way, guys. What does this mean? This means log base 3 of z plus, what is dividing by 2 the same as? Yeah. So this means 1/2 log base 3 of x plus 1/2 log base 3 of y. Guys, please don't miss this. What does the 1/2 power really mean? Yes, so this is really square root of x, and this is really square root of y. So then plus means to multiply them all together. So you'd have z times square root of x times square root of y, or just square root of xy. All right, so what I would like you to be working on, you need to finish all of this stuff and start working on 7A, and this is all the expanding in stuff, which is 185. So if you don't do some of that this, or all of that this weekend, it's just going to be assigned on Monday and Tuesday and Wednesday. So get started on that stuff. We have a quiz next Friday, and next Friday is the end of the next grade reports, okay?